An electrical control system senses inputs and makes decisions for a machine much like the brain and the nervous system do for the human body. The control system of a machine might perform functions such as start and stop operations, extend and retract actuators, sense and guide actuator motion, as well as turn motors on and off or even reverse them. Electrical control systems are classified as manual, semi-automatic, or automatic. Manual control systems require an operator to command each operation, such as pushing a button, activating a switch, or changing the position of a lever. An example of a manual control system is a human being controlling a backhoe. The operator must continually make decisions and perform operations manually to accomplish any task. Semi-automatic control systems require a manual input to begin the operation. However, the machine operation requires no further manual input except possibly to stop the operation. Many motor control circuits fall into this category. An example of a semi-automatic control system is a washing machine, which, once started, automatically cycles through the wash, rinse, and spin operations. Automatic control systems require no manual input to control the operation of a machine. Automatic control systems are operated by automatic input devices, often called pilot devices. Pilot devices react to conditions in a system. An example of an automatic control system is a heating-cooling system. A thermostat serves as the pilot device, which automatically monitors the room temperature and performs operations based on the information it gathers. Describe the 3 steps of a control process. The series of moves a machine makes to perform a task is called a sequence of operation. Each move in the series is called a step. It does not matter whether a machine is manually, semi-automatically, or automatically controlled. It still must perform the same sequence of operation even though each type of control system performs this sequence in a different way. For each step in a sequence, a control process consisting of 3 steps takes place. Input and logic. Once the input is received, and output. Once the brain has decided what to do, the action and output. Once the brain has decided what to do, the action must be carried out. If it is a manual system, the operator must perform another task, such as push a button, pull a lever, or activate a switch. On the other systems, the brain must cause the action to happen, for example, by changing the state of a set of contacts. Logic. Once the input is received, a decision must be made on what action to take for that step. This decision is made by the brain. In a manual system, the brain belongs to the human operator of the machine. The brain of a semi-automatic or automatic system consists of circuitry and components. It could be something as simple as an electromechanical relay or something as complex as a programmable logic controller or PLC. Input. An input must be received to indicate that it is time to perform a step. The input for a manual system is usually a visual observation that the previous step has been completed. For semi-automatic and automatic systems, the input might be a sensor that senses the completion of a step. Examine this sequence of operation that describes how an air conditioner keeps a room cool. For each step, there is a complete control process that takes place, including input, logic, and output. When there is a sequence of steps, the completion of one step by the output device is sensed by the input device for the next step. This sequence of operations can be created by connecting electrical input devices, logic devices, and output devices in specific combinations called logic. Describe the function of an indicator lamp and give an application. The most basic output device is an indicator lamp. Although it is available in many sizes, shapes, and types, the basic operation of all indicator lamps is the same. If it is receiving current, the lamp is on. The voltage rating of the indicator lamp is most often located on the base of the lamp assembly. Be sure to check the voltage rating of an indicator lamp before you use it. Operating an indicator lamp on the wrong voltage will in most cases damage or destroy the lamp. For example, a 24-volt DC lamp is not compatible with a 120-volt AC circuit. This is the ladder diagram schematic symbol for an indicator lamp. The letter in the circle indicates the color of the lens. In electrical control circuits, indicator lamps tell the operator at a glance the operating status of the machine. Indicator lamps have many industrial uses, including indicating that power to a machine is on, a cycle has begun or ended, a sensor has sensed an input, and so forth. There are a variety of lens colors available for indicator lamps. Each color indicates a different status. Indicator lamps are available for both AC and DC control circuit voltages. Common types include 24 VDC and 120 VAC. Describe the operation of a push-button switch and give its schematic symbol. Switches are used to energize and de-energize circuits by allowing or preventing the flow of current. It is much safer than simply disconnecting and connecting wires to open and close the circuit. The most basic type of input device used in electrical circuits is a manual switch. A manual switch is a type of switch that is opened and closed by a person. A maintained switch is a switch which holds its position once activated. The contacts will remain in their energized states until the operator is pressed again. A momentary switch contains a spring that causes the operator to return to its original position and the contacts to return to their normal states once the operator is released by the user. One application of a momentary push-button switch is the horn on an automobile. Automatic switches, on the other hand, are opened and closed by a machine or some other device. A limit switch is one example of an automatic switch. There are two main components of a manual switch: the operator and the contacts. The operator is the part of the switch that is touched by a person operating the circuit. It causes the switch to activate or deactivate. Electricity is transmitted across the contacts. When the switch is closed, a conductor, sometimes called a contact bar, connects the two contacts, allowing the current to flow. There are several types of manual switches available. Two common switches used in electrical circuits, especially control circuits, are the push-button switch and the selector switch. A push-button switch operator consists of a contact bar that is moved by the motion of the push button. In a normally open switch, when the button is pressed, the contact bar touches down on both contact terminals, closing the switch and allowing current to flow. In a normally closed switch, pressing the button pushes the contact bar away from the contacts, opening the switch and preventing current flow. These are the schematic symbols for normally open and normally closed push-button switches. Connect and operate a basic electrical control circuit that uses a push-button switch. In this procedure, you will connect a simple circuit that includes a push-button switch. You will then operate the circuit using the push-button switch to change conditions in the circuit. Select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other.